rate of change, instantaneous rate of change. So we know that rate of change is related to the first derivative, and the first derivative is also the same thing as the velocity. So, but instantaneous rate of change of a function is found by taking the first derivative of that function, which is similar to velocity or the same thing as velocity. Also, reaction, growth, and density are also rates of change. So whenever you see a problem that involves rate of change, you're going to find the first derivative and then plug in, obviously, the value probably t into the first derivative. So here's an example. When a person starts to run, their pulse is so many beats per minute, and it's given by this function pt equals 56 plus 2t squared minus t. Find the rate of change. So it's asking for the rate of change when t equals 5. So again, rate of change means the first derivative. So if I'm finding the first derivative, it equals 4t minus 1. And then I'll plug in the value t equals 5 into the first derivative, and I get 19 beats per, supposed to be per minute, but the reason I put a question mark there is because who has 19 beats in 1 minute? So that's why I just put a question mark there. I'm not sure if the units would be correct in this, if this was a real person. In the second derivative, it says that a spherical balloon is inflated. Its radius in centimeters after t minutes is given by this equation, where time goes from 0 to 10. What's the rate of change with respect to t when t equals 8? So since it involves rate of change, that requires us to take the first derivative of the equation, but you can see that you have a cube root here. So I'm going to change the equation to 3 bracket t plus 8 bracket, and since it's cube root, it would be to the 1/3. And now I need to take the derivative. So the derivative, I need to apply the chain rule. So the 1/3 gets multiplied by 3. Subtract 1 from the exponent, and then I take the derivative of what's inside the brackets. So by applying the power rule, 3 times 1/3, subtract 1, which is 3 over 3 from the exponent, so that's why I get t plus 8 to the negative 2/3, and the derivative of what's inside the brackets is 1. I'm going to simplify this, and you can see here that 3 times 1/3 would become 3 over 3, which equals 1. And since I have a negative exponent, negative 2/3, I'll bring t plus 8 in brackets all to the negative 2/3 into the denominator. So I'm just going to simplify this. I get 1 over the cube root of t plus 8 in brackets all squared. Now I can substitute t equals 8 into the derivative because I'm finding rate of change. Substitute 8 in for t, simplify it, and I get 0.157 centimeters per minute. So what's the rate of change as the balloon is being inflated after 8 minutes? So the rate of change with respect to t equaling 8 is 0.157 centimeters per minute.